All right, we're back. We're going to be on page 5 of Notes 13 of Calc C. We're talking about Euler's method. So on this, if you are looking at the PDF on a computer, these links should be clickable. If not, I don't think I can click them right now, and I haven't checked them in years. I assume that they're still valid. I don't know. You can get to some older YouTube videos that I made of me using the calculator to do Euler's method in 3 different ways. So the graphing one is the one that I kind of like default to because it's definitely the easiest one. On the calculator page is definitely the coolest one. And then using a spreadsheet is just like, if you want to get to know how to use your calculator better, how to use a spreadsheet a little better, it's very cool. But I would not, like, in the middle of an exam or anything, try to bust out a spreadsheet and do this. So the first 2 I think are really useful. I'm going to show you how to do the second one as we go through these problems, I think, because it's I think probably the easier way to like get your table set up. So we're going to use Euler's method, indicated step size to approximate the indicated value of the function, show your table, use your calculator for calculations. Okay, thankfully we can use calculator. So we're going to set up the table. So it's always x, it's y, and then dy, the approximate change in y. And then, okay, so what are we doing here? We know 2, negative 1. And then this is going to be f prime of xy, delta y, oh my god, delta x. Okay, that x is terrible. Killing it, people, killing it right out of the gates. All right, now our delta x is 1/5. So this is 10/5. So we'll get 11/5, and then we'll get 12/5. So we don't have to do that many steps. And now we have to calculate, right? So it's going to be 1/5, which is your delta x, and then x plus 2y. So x plus 2 times negative 1 is actually 0. And so I see a lot of people who see that and they're just like, oh, okay, so it's always going to be 0 and we're never going to, like, we're stuck, right, on like a horizontal line or something. Not the case, because when you add these together, you get negative 1. Now when you recalculate this using this point, you're going to get something different. So you don't get stuck there, even though you might think you did. So 1/5 x, which is 11/5, and then 2, so minus 2. So that's 1/5 of negative of 1/5. That's 1/25, maybe? I don't know. So then we should add these together, and that would give me negative 24/25. Nothing about that feels right, but I don't know. I don't see like an obvious mistake. So perhaps I made a not so obvious mistake. All right, let's go to the calculator and see if we can learn how to use the, so I'm not going to use the graph page. I'm going to try to do it on the calculator page. And you do that by just typing Euler, but like it's so hard to remember what to type in. So what I'm going to do is I'm going to go here. Honestly, I just think this is generally hard to remember. So what I would do is I'd probably write this on my paper as you go into, so I press catalog. If you type the letter E, it'll bounce you down to all the E's, and then you can just like arrow down until you get to Euler. So it's built in, and you can see that you need an expression. So the expression is the derivative, so you can type that in. Then you need the independent variable. I don't know why it doesn't say independent variable there, but anywhere it says var is independent variable. So that'll be x for us. Then you need dependent variable, that'll be y. Then you need where the variable starts, so like the x min, or well, the x min, where you're starting. And then the variable max actually just means where to stop. Then you need to know what the initial dependent variable is, so that's the initial y value. And then the variable step. So the order in which this falls is like crazy to me. And then Euler's step. Do I remember what that does? Maybe. I think that tells you like what do you want to see in the table. But let's do a problem first. That part's optional. So I'm going to select this. I actually screenshot that so I can remember what to type in. So I'm going to do x plus 2y, comma. All right, the variable, so the variable is x. That's the independent variable. Then y is the dependent variable. Now we got to do a list. So that's shift and then close parentheses to get your braces. And then you're going to start at 2, and you're going to end when you get to 12/5, because that's what you're approximating. Get out of there. the initial dependent variable is -1, because that's what y is when x is equal to 2. And then the step size is 1/5. I'm gonna press enter. Okay, so, and that's what we had, right? That's our table right there, 2, 2.2, 2.4, and then -1, -1, -0.96. Because if you get a 24 out of 25 on something, you know you got a 96%. So 0.96, it worked. There was that like optional argument. So say I did, you know, I don't really know what this is doing. I'm gonna say this. So like 2. That did something. Oh, you know what it's, I think I know what it's doing. So it's, let me say 1. Okay, here's what it's doing. It's the 1/5 that you see here, if you don't use the optional argument, which like just don't use it, but if you don't use the optional argument, the 1/5 is telling you like start at -1, start, no it's not, it's saying start at 2, because that's what x starts at, and then add 1/5, 1/5, and keep going until you get to 12/5. So there's like a back and forth here. If you use, and then what I'm doing is I'm saying use Euler's method once in between those. So the one, if you have the optional argument, what it's doing is it's going to, in the table, show you 2, and then what happens 1/5 after that, and what happens 1/5 after that. But it'll use Euler's method as many times as you tell it to. So if I tell it to use Euler's method 10 times in between, the table's still going to go 2, 2.2, 2.4, but it will have used Euler's method 10 times in between. So it will have a much smaller step size. So that, I mean, that like, depending on how you, that could be confusing. I would say just like, don't use it because we don't actually need it. You need that if you're going to do like 10,000 steps and you don't want a table with 10,000 columns. But we're never going to do anything like that. So I think that's good. I'm going to do one more while we're here, I guess. And then maybe come back in the next one and do some. I don't know. We'll see. See how long this takes. I think I'm going to mess this one up pretty badly. So, you know, so there's that. Mostly because delta x can be negative, right? Which means you're just going to the left instead of the right. So it's not a problem. It's just, it's not a problem, it's a feature, you know? Okay, so -3 and 4, and then this is going to be f prime of xy delta x. So the thing that everyone forgets is delta x. Delta x is negative. So if this is negative, we're going to go here and then here and then here, right? And we're adding delta x every time. But in this case, delta x is negative. So -15. So this will be -16 fifths. That was hard. And then -17 fifths. So we're only doing 2 steps, which is great because the more steps, the worse. So this is -1/5 is delta x. And then we have to do the opposite of x over y. So the opposite of -3/4 is +3/4. So this is -3 over 20. So I want to keep doing this by hand. I mean, the answer to that is never yes, but should I? 80, so 77 over 20. So then we'll get -1/5. We have to do the opposite of x over y, the opposite of this over this. I'll work that out over here. So I need 16 fifths times 20 over 77, which I guess is 64 over 77. This is where I'm going to stop doing this by hand. I need to, ooh, look at that, auto shape. I feel if I needed to make that circle, I wouldn't be able to, like guaranteed. I don't want to do that by hand. So I'm going to check it on the calculator. I'm going to add as soon as I get to the calculator, I'm going to try to like add those together. And then after I add them together, I will see what happens. Negative. Okay, so that, yeah, let's see. Here we go. Back to the calculator. So I want to just do 77 over 20. This again, there's no reason to do this because I'm just going to use the calculator. But like, let's see how wrong we are or right we are. Who knows? So that's a thing. All right, so 3.68377. So now what I'm going to do is I'm going to try to remember how to use Euler's. Euler, I got to do the opposite of x over y, comma x comma y, comma, x starts at -3 and ends at -17 fifths. Which is like a little confusing because in the description it calls that like the maximum for the variable, but it's like, I don't know, the farthest. I don't know what you would call it other than that. So, you know, I probably would have gone with that too. Dependent variable starts at 4, and then the step is -1/5, and I just want to use one Euler step in between. Like I don't want to like do 5 Euler's methods in between. So yes, so we got it. So I'm gonna fill this in the table. 3.684. Say f of -17 fifths is approximately 3.684. And there you go. I mean, should I just do the other ones while we're here? I don't think I should, because I don't know. I'm gonna do one more. So maybe I'm gonna just use the calculator to like get the values. Is that cheating too much? Kind of. The next problem, I'm going to do it anyway. The next problem is x plus y, comma, x comma y, comma, x starts at 0 and is going to end at 1/5. And then the initial y value is 1, and our step size is 1/10. At least we're only doing like 2 steps every time. So this seems like it's not going to be terrible. So I have that on the calculator. I'm going to go back, so I know I'm going to get 1.22. Let's go back. Well, unless I did it wrong. Always an option. You gotta leave a window there, you know, just in case. You don't want to be like, I never get anything wrong. I think we all know, get a lot of things wrong. Ooh, that's like a partial derivative sign. We don't even know what those are yet. dy. F prime of xy delta x. All right. Okay, here we go. So it's 0, it's 1, and then it's 1/10, and then x plus y is 1. Okay, so we add those, we get 1.1. This will be 0.1, and then 0.2, or 1/10, 2/10, so 1/10 and 1/5, and then it's going to be 1/10. X plus y is 1.2, so that's 0.12, and then we add those, we get 1.22. Killing it. So y of 1/5 is approximately 1.22. You can put a 0 if you want 3 decimals. That was so fast. I'm gonna not do the next one. I'm gonna wait for the next video for this one, because then we have to talk about other stuff, and I want to like have enough material for the video not to be a waste of time. All right, so I'm gonna stop here. I'll be back in the next one, and I will see you there.